All right, Jean and Gavin, they're going to go ahead, and they already tried these in the back of their homework spirals. AP practice. Go ahead and pause the video now and come back when you're ready to listen to the answers. Okay, sorry, you guys. C and A? Good. What about number 1? What were you thinking through? What were you thinking through? Come on. Not everybody got the right answer.
Yeah. I know.
So how'd you narrow something down? Someone tell me something, they said, nah, couldn't be that, and why?
Couldn't be A.
I heard couldn't be A first. Couldn't be A, why? Everything else was a fraction except for A. So process of elimination, he's the weird one out, right? Weird one out, that's like a life thing we should totally be doing all the time. Okay, with AP, that's somewhat safe. And yet, at the same time, someone tell me a reason why. If X was a negative, wouldn't all of these be positive for positive Y's? What quadrant am I thinking about? Quadrant 2. Any of these X's are negative as the Y's are positives. A positive minus a negative is a positive. Are all these sloped up? No, that doesn't make sense. If you were in the second quadrant in that one, they should all be sloped up, and they're sloped down. Well, that's a bummer. So what else also wouldn't work? Because of the same similar logic or rationale. Second quadrant, I have a negative X and positives Y's. But I need it to go down. What else can I take out right now? B, yeah, because a positive minus a negative would be a positive. Those are not positive. Okay, sorry. Your turn. What else can we take out? Why? Oh, because in the first quadrant, a positive and a positive plus a positive, a positive plus a positive, there would be no way for it to go, do you see? Positive, 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 negative. Now, the negative is awkward. It's for a small x and a high y. But a positive plus a positive, a positive plus a positive will always be positive and never turn negative. So let's see. Why does letter E work? If I have a small x and the y's get bigger and bigger and bigger and bigger and bigger and bigger, will this eventually turn negative? Yes. If I have like x is equal to 1 and y is 1 and 2 and 3 and 4 and 5 and eventually. Does anybody else have a reason why they chose E and not C or D or B?
Yeah, when x is 0 and y is positive, the slope is negative.
Nice. When x is 0, then he's looking at the axis, and that's something that we would do last year, is look for the signs in the quadrant, look for horizontal tangents. You guys realize there weren't any really easy horizontal tangents? Like, there's one right there. Not quite sure what the units are, but when he was looking at the axis. X is 0. What happens? X is 0, and y is getting bigger and bigger. X is 0, y is getting bigger and bigger. It gets more and more negative. Good. Or y gets lower and lower and lower, more positive and negative. Any other reason someone made the E match besides what's already been discussed? How many of you made the E match? Like 5 people. So, what is this a hard one?
Well, I did read.
Oh, okay, let's try again then. Actually answering my question. How many of you guys got E right? Oh, that's better. Okay, so half the class. Still half the class got it wrong. Okay, that's not great percentages as far as our class odds. So number 1 was E, but good job. I'm glad that more of us did. Number 2 was what? C, and then number 3 was A. The work is on the sideboard. Any questions on 2 or 3 before we go to the FRQ, the free response question? Yeah. Number 2. Number 2 gives us the integral. Why is it a weird question? It's a great question, but it's a weird question. Does it give me a u sub? It gives me a square root of x sub. What? What's going? Well, okay. They can do whatever they want. And I'm going from 0 to 1/2, right? Okay. Could I, right now, come over here and say sine of y? Oh, this is easy. Now it's hard.
Miss C, do you have any tissues?
Oh, both boxes are out? Yeah, I suppose so. Well, I do have napkins, but I actually have more tissues than I have napkins. That's very dirty. I want to open that one in front of them. Just have to take it back. Oh, you guys just lost all the work. Sorry. Okay, we need to plug in a whole lot more. We need to get rid of our bounds, we need to get rid of our dx, and we need to get rid of our x. X, we don't have x, exactly, so make him. How do we make x? Square both sides, so x is equal to sine squared of y. Why did I do that? Because I have to plug in just an x. Okay, so square root of 1 minus sine. What else do I need? How do I get a dx? By taking a derivative. How do I take a derivative? Well, you have a couple different options. I took it way back here. I guess you could take it here. Derivative of x is 1 dx, if you want to think about it that way. And derivative of sine squared of y is 2 sine y cosine y dy. You could have also done 1 is equal to 2 sine y cosine y dy dx and move the dx. That works. Could have done implicit differentiation, kept the dy and moved the dx. But either way, well, okay, that's how we get rid of the dx. But what else do I need to get rid of? The bounds. So aren't these x bounds because of the dx? So we take this and we say, all right, let's plug in. So I'm going to plug into this guy just because he was my original expression. I guess you could plug in there. I just didn't to. So square root of 1/2. What does that get me in terms of y? And then square root of 0, what does that get me in terms of y? People that made the match before I said it was c back there, how did you solve for y? But how did you guess? It was an educated guess, right? Because you had to think of trig.
Oh, I narrowed it down to C and E before I guessed because I couldn't see the bounds.
Okay. No, that's good though. So she just went ahead and went simplifying and said, okay, I'll figure out the bounds in a second because the expressions were different. Draw a triangle or just think inverse trig, right? Trig backwards. So sine of what angle is? Sine of what angle is? Oh, 0. That's one we should know. Hey, you guys realize that we're doing a unit circle stuff in pre-K? 1, 2, 3, 3, 2, 1. All over 2 square root of 3, 1, 3, 1 square root of 3. Sine is the first one, right? So katoa. Sine's the first one. 1, 2, 3. Sine is 0 at 0. And then it counts up to 1. So sine is 0 at 0. I knew him pretty quickly. This guy, since when do we see, well, square root of 1 is 1, square root of 2 is root 2, and then couldn't you rationalize him?
Yeah.
Who's square root of 2 over 2? Ew, it's a pi over 4. Or at least, don't you know that's not pi over 6, which is 1/2? You know it's not 1/2.
I don't know the cheater chart.
I like the cheater chart for tangent. Square root of 3 over 3, 1 square root of 3. It's faster for my brain to process. So then you were able to make the match to C, where you had the correct bounds. Oh, sorry, I didn't simplify yet. My bad. I just kind of did the rest. Yeah. No, I haven't simplified yet, right? So I have sine times sine is sine squared. The 2 comes out. I have a cosine. Hey, guess what? In honors, no regular pre-calc. We just introduced the idea of t-proof. That's going to take us a whole chapter to get back to. But t-proof. Why am I saying t-proof? So what's 1 minus sine squared? Cosine squared. What's square root of cosine squared? Absolute value of cosine. Okay, a little bit awkward, the absolute value thing. But out of all the answer choices, the only one that kind of matches is, oh, hey, it's from 0 to pi over 4. Am I going to have any negative cosine values from 0 to pi over 4? No, the absolute values are redundant. Oh, I can simplify. It's legal. It didn't make a mistake. And the answer is dun, 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 dun. Dun, dun. Okay. Are we okay on 1 and 2 and 3? Yeah. What's it time for us to do? I'm thinking number 4, but Number 4. Let's not quite. We have a differential equation. Is this the very, very, very beginning? Is this possible for us to separate and integrate or not? No, there's a minus. So can you be asked, can you be told that you must integrate this? No, because you don't know how. Okay. The slope of the differential equation is shown below. Sketch the solution curve. Oh, that's easy, right? Well, for me it's easy. Sorry. Graph it, and then you just go, swoop, there it is, ish, right? Okay, how about 0, -1? Right? Seems to be some sort of like slanty asymptote something going on. Or at least some sort of flow that's going through. But then letter B and letter C got all sorts of interesting because all of a sudden you see solution to differential equation. And if you guys remember from last year, quite a few of you would be like, we have to go back and solve, but you don't. It doesn't say find, it says let. Or it is a solution. Find this value of B. What have you guys thought of so far?
Can we substitute y on the original equation?
Yeah, we could do that. Because if it is a solution, then it would be a y, right? So we could do 2 times 2x plus b minus 4x.
And we could integrate these constant.
Good. But if you integrate, aren't you going to theoretically get back, because the integral of dy would be y, you just get right back to where you are. But you could set them equal to each other. But is there a faster way? Instead of integrating this, why not derive that? Instead of integrating this, why not derive that? Because doesn't this dy dx need to match up too? What's the slope of him? Oh. So what can I set the derivative equal to? You see it? The slope of this has to match up with the derivative of that. And the derivative, well, I mean, if this is a solution, this is his derivative. So therefore, for him, you're totally right, Kevin, it was important to plug in that 2x plus b into the y spot. But then we can also say that dy dx, for this to be a solution with a slope, a constant slope of 2 must equal to. And now all of a sudden, I haven't had to integrate, because this would only be like a 1 or 2 point problem, probably. And so all that work would take a little bit of time. Not tons, but some. Because then it's 4x minus 4x, okay, and then 2b, and then 2dx, and so we would end up with the same thing up, right? 4x minus 4x, and then 2b equals 2, so therefore what does b equal? Got it. Justify your answer. I don't like that they put that. I think they're just saying show your work. The AP wouldn't ask you to justify that answer. I mean, I guess you could go talking about how if this is a solution, then his slope must match up with the differential equation, but that's kind of basic for an AP to ask. But then letter C says, let G be the function that satisfies the given differential equation. So G is not a solution, it's the solution equation, with the initial condition of G of 0 equals 0. It appears from the slope field that G has a local max at the point 0, 0. But how can we prove analytically that so? What are you talking about? Doesn't it look like there's a max there? Yeah. But how do you prove it's true? Oh, sorry. Hey, what's calculus AB learning right now? Increasing, decreasing, and then tomorrow, without me, but with a video, they're going to learn the first derivative test. Hey, they're going to learn your lesson from last year. First derivative test, was that a way of finding a relative max? Yes. How does it find a relative max? You find a critical number, and then you check the sign of the first derivative before, which better be, if it's a max, better be a positive derivative, changing to a negative derivative, but you have to know values of the derivative before and after. But what are they going to learn in section 3.4? That's an alternate method for relative extrema. A second derivative test. Do you still need critical numbers? Yes, they're the only candidates for relative extrema, but instead of needing the before and the after exact derivative values, now all you need is the second derivative at that point. Is the second derivative positive or negative? So in this one, if they've only given us 1 point, what do you think we're doing? A before and after or an at? So a first derivative test or a second derivative test? So how are we going to do a second derivative test? Well, don't we have to Derive? So therefore, my second derivative, d squared y over dx. Wait a minute. The second derivative isn't enough for a relative max. I need to know what's a critical number. Oh, so what should we technically have done first? Checked. What's dy dx at the point 0, 0? 0 minus 0. Okay, is it a critical number? Yes, the derivative is 0. If you didn't put that, you would not have gotten full points on the AP because it has to be a critical number first. And then what can you go looking at? The second derivative. And what's the second derivative going to equal? 2 dy dx. Yeah? Yeah? 2 dy dx minus 4. Can I plug in 0, 0? When I plug in 0, 0, 0, 0, 0 minus 4 is negative, and negative is less than 0. Booyah. How would you use your words? How would you use your words? Life lesson. 2. Bring it home.
So, since the second derivative is negative, that means the function is concave down. That means there's a relative max at that point.
Almost. You would have missed a point. What did you miss? In his words. It would have been on his paper, but not in his words. Huh? You actually don't have to say the second derivative test. You have to say, since the second derivative at the critical number 0, 0, got it, is negative, then there must be a relative max. If it's just negative, if the second derivative is just negative, all I know is concave down. But at the critical point, I know it's a relative max. Is that cool? Got it. All right, let's go ahead and grade homework. Where did the tabular method show up? Second problem? Oh, somewhere near the middle. Okay. So let's get to somewhere near the middle, and then, in case you're curious, I do have this little page of notes saying, what about the tabular method? Ooh, that looks fun. Some of you figured it out already. Some of you went looking for it online using your resources. That's a good skill for college. Teachers don't give you everything in class. Anyway, moving on. Section 7.3. Oh, it reloaded. I had it ready to go. Okay. Number 2, did you guys get x times e to the x minus e to the x plus c? Did you write your plus c's? Ooh. Number 8. Number 8, 1/3 t cubed ln t minus t cubed over 9, or 1/9 t cubed plus c. If some of you guys are factoring things out, it's not bad as long as you keep the c separate. Because if you're pulling variables out, you can't have c be in the front of c. You could factor out something in common here, but they probably won't because of the c. If you did, you just have to separate that with parentheses when you factor. Maybe you're not thinking that at all, so never mind. My brain would have thought. Number 20. Were you guys super careful with your loop sign being a -1? Wait, I chose sine of 2x as my u. That's okay. It would have worked either way. They're both loopy. You just need it to loop around to become a like term. So pause. If you did not choose u to be an exponential, you should not be writing anything down except for the final answer. Because their work is not going to match up with yours. But if you did choose u to be the exponential, you can be checking it in between steps. The final answer is -1/5 e to the u 2 cosine of 2x plus sine of 2x. They did pull out the e to the, so maybe you would have had yours multiplied in. Doesn't mean you're necessarily wrong. Just think about it with that distribution. They were both negative, both with, well, he would have had a 2/5 and he would have had a 1/5. We can look at it if you need to. I just want to give you time to check the answer. Joe.
For BC, you usually people usually get to a stage where they do not have to write DV and U and DV, or throughout BC.
Meaning, do we kind of do integration by parts with mathematics?
Last year we did. So.
Can I just leave this here for you to hang somewhere?
Not usually. There might have been a few at the end after doing but not usually. Just because There is the possibility, Joe, that they give you something super basic like x times sine of x that you could theoretically do mental math style, but there's also the possibility of one that needs like multiple iterations, and it'll be so much safer just to show you. So I'm not telling you absolutely not, I'm just saying it's super dangerous. There we go. Do we have more evens? Is my computer frozen? Yes, that's fine. Okay. Ah, tabular method. Who is this guy? Okay, pause. Keep your homework spirals just as they are, but let's go peek at notes real fast. Hey, what's in common between my example, x to the fourth sine of 4x, and this example, x cubed cosine of 2x? What's similar? Who would you use? Keep your homework spirals right where they are. You guys are awesome. You know it. We're going to keep grading, but notes. Let's pause and talk about tic-tac-toe. Or tic-tac-toe-toe-toe-toe. It depends. Tic-tac-toe is only if you needed 3 integration by parts. Well, actually 2. Why does it say repeated application necessary? Can you guys tell just by looking at the pieces now that you've practiced it? Who would you make x to the fourth? Because will sine of x break down at all when I derive? No. Well, x to the fourth becomes an x cubed. I know it's not gone, but it's simpler. And it's not a loopy example because I don't have 2 that'll just keep on looping for forever, so that's not going to help. Okay. Also, Joe, the whole idea of you possibly doing like U substitution mental math and having to remember a formula and plugging it in appropriately with a minus. So, just thinking through like my rationale as to why I'm saying that. Integral of sine is cosine, but it's going to be a negative cosine, so I have my 1/4 cosine of 4x. So many places to make mistakes. My u, x to the 4th, du, 4x cubed. Okay, did we get the process down last night? Why do I say lucky 7? Because if you've set it up the way that I have, doesn't it make a 7? U, v minus v, du. Or ultraviolet v, du. Either way. You end up with, okay, negative 1/4 x to the 4th cosine of 4x minus the integral of, oh, well, that's a negative, so that's going to be a positive. And then I'm going to have 4 over 4, which is just going to be a 1. And then that x cubed is the resulting integral simpler. Yes. Is it ready to be integrated right now by hand? Final done. No. And what would have happened if I had gone again? Gone again? Come on, you guys had at least 1 or 2. You had to go multiple times last night, right? So if you went again, you would have your x cubed, and you would have your 3x squared, and some of you were like, oh, this is so tedious, I'm going to have to go again. That's when the tabular method is kind of nice, not for loopy examples, but for ones where it is getting simpler, just it's taking some time. My integral will be 1/4 sine of 4x. There we go. I'm doing multiple iterations for a couple reasons so that you guys can fully understand the tabular method. Because remember, when you go to plug this in, I have my negative 1/4 x to the 4th cosine of 4x. That's still there. Then I technically have my minus, whatever that stuff was, but minus the negative turned into a plus. But now I have my new lucky 7 from my new integration by parts. So I'm going to have a 1/4 x cubed sine of, 4x. Minus, so I had a minus out here, and then it combined with that one to be a plus, but now I have another minus on the inside, minus the integral of, okay, the 3 and the 4 comes out, and x squared. Can I go straight to an answer yet? No. But is it simpler? Yes. What we have to do? Keep going until we get to an integral where all the x's have finally been derived away. There's only a trig remaining, and I can take a quick derivative of it and be done. So what's the other way? The other way says you're going to have to do it a few times. So why not just, make a patterny thing, saying we're going to have to do a lot of U's to DU's and a lot of DV's to V's. We're going to have to do a lot of U's to DU's, and then those DU's to be used to be DU's, and then those DU's to be used to be DU's, and a lot of DV's to be V's, and then those to be DV's to be V's, and then those to be DV's to be V's. I think there's kind of like a pattern going on. What happened to U's? Well, U's get derived, right? Just go until you can't derive anymore. Second. DV's get integrated. I could put a dx, I'm just being lazy, and simplifying the notation. So that'd be -1/4. And then that'd be a -1/16. Then that'd be a +1/64. And that'd be a +1/256. That's 24, right? And then that'd be a -1024, right? Powers of 4. Do you guys see anywhere this first term of the integration by parts in that table? It's a little hard, right? Because you're like, but the x to the 4th is there, and then the -1/4 cosine of 4x is there, isn't it? That guy? Question: was the sign the same or different? If you were just to multiply these two right now. Same, right? Because it's a negative here and it's a negative there. Hey, can you look at the second? The second UV, the next UV, wasn't it this guy? Do you see him anywhere? It would be x cubed. Oh wait, 4x cubed. Oh wait, 4/16 is 1/4x cubed sine of 4x, but it's a negative. Haha, this one's a positive. Yeah, and it's always going to be the opposite sign. This one's the same sign. No, it wasn't positive. I know, I didn't say it was positive. I said it was the same sign as the multiplication. This was the opposite. A negative times a negative will be a positive. Oh, is that going to keep happening? And the answer is yes. The first term is tick. The second term is tack. The third term is toe. Except in this one, was tic-tac-toe enough? Nope. Tic-tac-toe. Oh. All right, well. Stand and deliver only got us so far. But tic-tac-toe-toe-toe. But that's my answer. What? If you were to keep doing your integration by parts and get all the way down to the integral where all the x's is gone and the trig is there, you would end up with a constant times. So what's my final answer for this guy without having to do over? Look at what I did. It was boom, 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 boom. And then just tic-tac-toe-toe-toe. My final answer is that -1/4 x to the 4th cosine 4x plus 1/4 the minus a negative positive 4/16 1/4 x cubed sine of 4x plus a positive, okay, so plus 12/64, ew, 12/64, I mean, one goes in like a 4. So 3/8 x squared cosine of 4x. Is it? 4 goes in. Oh, I did 4. I don't know what I was dividing by. I was dividing by 6. Thanks, Maggie. 3/16 x squared cosine of 4x. And then minus a positive, which is a minus. 24/256. That would be 3/6. No, 8 goes in 32 times. 8 goes in 3 times. 8 goes in 30, and then 16. Yeah, 32 times, right? Hey, I think there's a pattern. Maybe I could be using it. Maybe not. And that is x times sine of 4x. Oh, I'm so close to fitting it. That's okay. And then we'll do a minus. Plus, but it's a minus, so minus. And then 24 over 1,024, what goes in that time? 12, 8, 3 went in, then 8 went in, then we do 12 and 5, 12, but we can go more than that. 4 goes in, 6 and 2, 56. We can do another 2. So 8 goes in, 3 and 1, 28. Ah, poo. So close. It's okay. Cosine of 4x. Dun, 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 dun. 8 goes in 1. And that'd be 22 and 2 and 64 and 8. I think it's 128. Double check with me. 8 goes into 10, 1 time, 22, 2 times, 64, 8 times. Joe, we're good? But here's a quick warning. This means keep the sign the same. So the negative stays. Second. This one means opposite. So flip the negative to be a positive. The whole reason is, guys, every time you do ultraviolet voodoo, you have UV minus an integral. But that integral is going to become a new integral, and it'll be minus and minus. The next time it'll be minus and minus and minus. The next time a minus and minus. So every pair is going to be keeping it the same. And every odd pairing is going to be flipping the sign. That's why it's like same, opposite, same. You're just multiplying the two together. Opposite, same. So some of you are like, I have no clue what's going on. Well, you try it. It's a lot smaller. It's only x squared. But still, x squared, if you started with him being your u, wouldn't you be able to take at least a couple derivatives? Can you tic-tac-toe it? Yeah.
Okay, 2 questions. So number 1, does tic-tac-toe work for all the non-looping
Repeated applications.
Yeah. And then number 2, I know the guy called it tic-tac-toe, but like, why?
I think he was just, maybe he had only done ones where there were 3. My guess is that he was just saying, like, he saw it was going to be like a 1, 2, 3 done, and tic-tac-toe is in like a set of 3. My guess is it just was like off the cuff. Not literally like the actor, but possibly they did try to keep things very accurate to half the time. Because, yeah, it's only going to be that one. Yeah. You were back? No. Okay, so you guys are practicing, but when we're supposed to be grading, I'm going to go ahead and quickly come over here. I'm going to scroll through the rest of the evens. You can see the tabular method, which you could have done by hand. You didn't have to use a table. It just would have been gross. Then you have, I think, just 2 multiple choices, and we're done, right? B and C. Okay, here's a dilemma. Am I here tomorrow? No. So, am I going to be able to answer all your questions on section 7.3? No. Wait, and we have a whole new section we're supposed to do for homework that's due after the weekend. But what's the title of the next section? Exponential growth and decay. Have we done growth and decay before? Yes. Didn't I tell you 7.1 had Eulers, and then it also had split fields, and then 7.2 was review, and then 7.3 was integration by parts, it's new, and then 7.4 is review, and then 7.5 is logistic growth, it's new. Our next section is review, so hopefully when you guys watch the video tomorrow with me from last year, it'll be okay. Alright, if you guys want your test, you can grab it on the way out the door. If you don't want the test, you can just leave. Lorenzo, I have yours. Lainey, I have yours. Patricia, I have yours. AJ, I have yours. Hold on to yours. Abby, I have yours. Yours, I have, oh, sorry.
I gotta go make my mac and cheese.
Yours. John, you if you want it. David Brozu if you want it. David Lewis if you want it. Victor if you want it. Here's John. Here's a Victor. I have a Kevin. I have a Christina. I have a... Oh. I have a David. I have a 10. I have a Jayla Price. Who's right? I have a Jacob. Who is right here. And I have a Ryan who is right.
Thank you.
Welcome. And Lainey, you got yours?
Yeah.